All right, welcome back. So I looked at the trapezoidal rule, but it's not the only rule that's out there. In fact, there's a ton of them, but they're not always all that nice or great to use. So the trapezoidal one, like that one's okay. It's not that complicated. And then this next one, Simpson's rule, this one's not quite so bad either. Simpson's rule, it came about because instead of using trapezoids, Thomas Simpson, he found a way to approximate a function with a second degree polynomial or some sort of parabola. So let's see what his rule says. So this is when n is even. So you're dividing it up into an even amount of partitions or sections. So let f be continuous on that interval. So Simpson's rule for approximating the definite integral from a to b of f of x dx is, and again, it's got that approximation. It's b minus a over 3n times f of a plus 4 f of x sub 1 plus 2 times f of x sub 2, and then it alternates 4, 2, 4, 2, 4, 2, all the way down so 2 f of x sub n minus 2 plus 4 f of x sub n minus 1, and then plus f of b. So it's really similar to the trapezoidal rule. It just has a 3 on the outside in the denominator instead of a 2. And then on the inside here, they're not all 2's in the middle. It's 4, 2, 4, 2, 4, 2. Okay, now as you smash more of those partitions in there, as you let the number of partitions go out to infinity, the right-hand side approaches the definite integral from a to b of f of x dx. Okay, so let's use Simpson's rule to approximate that definite integral. So it's with n is equal to 4. So you have 4 subintervals going from 0 to 4. So they're all equally spaced. So each sub-interval is 1. If you're going from 0 to 4 with 4 of them, each one is 1. Okay, so it's approximately equal to, and we're going to follow that formula out. So b minus a would be 4 over 3n. So 3 times 4. So we're going to start with f of 0, since 0 is the lower bound. And then plus, it's going to start with a 4. Oops. Our next number we're going to plug in is 1 from 0, or 1 away from 0, so 1. And then 2, f of 2, and then it's alternating 4, 2, 4, 2, 4, 2, 4. So 4, f of 3, and now I'm at my last number, the 4, so then there's no coefficient. Then just start working them out. So the fraction out front is a third. Okay, plug in the 0 in for x, and we get 1 plus 4 times plug in the 1, and we end up with a root 2 over 2. Plug in the 2, root 5 over 5. Plug in the 3, root 10 over 10. And then finally plug in the 4, root 17 over 17. And we're not using calculators, so just simplify what you can simplify and leave them with radicals and fractions. So 1 plus 2 root 2 plus 2 root 5 over 5. Oops, that should have been a 10 down there. Plus 2 root 10 over 5 plus root 17 over 17. And just leave it like that. Okay, so that is a pretty good snapshot of how to use Simpson's rule. So the next video we'll look at this example 4.